last time, right? Forced convection, actually we can see that from two perspectives. We can categorize the questions, the problem into two categories. Number one is flow inside tube, right? Inner flow. Then case number two is external flow, internal flow and external flow, right? So under internal flow, we need to first calculate the Reynolds number. Then from there, we decide which formula to use, right? Of course, there are some special cases, for example, liquid metal, but you cannot run away from this basic, right? Then case number two, external flow, then it depends on the geometrical shape, right, of the surface. Okay, so you have gone through all this. Then Dr. Nadia has already demonstrated how to use all those formulas. Okay, so this is a general formula for external flow, right? So this value of C and M depends on geometry, right? So you cannot run away. So your purpose is to get Nusselt number, because Nusselt number contains H. Then from H, that when you get Nusselt number, then you'll be able to calculate H. Okay, so the value of C and M actually depends on the shape, okay, the geometry of the surface, right? And after that, you went through different example. Okay, I just want you to see, okay, I think to some of you, maybe this flow past banks of tubes or cylinder is a little bit confusing, because it requires trial and error, right? But that is why this particular part is important, because it is actually related to another topic which you are going to learn after this. Okay, after the sem break, right? After the sem break, we will enter this topic called heat exchanger, right? Heat exchanger. So this is why you must learn. You need to have basic understanding on this, okay? Because this banks of tubes is actually a part of heat exchanger. So if you still remember, you'll be given a project, right? Group project requires you to design a heat exchanger for certain process. Okay, so actually, this is how a heat exchanger looks like, something like this. Okay, heat exchanger is an equipment, a very common equipment used in chemical plant, okay, to do heat transfer, right? Let's say you have a process fluid, right? You have a process fluid which is too hot. You want to cool it down, right? You want to cool it down. Or you have a process fluid which is too cold. Then you need to heat it up. Okay, for example, let's say you have a reactor here. Okay, you have a reactor. So the temperature required for the reaction to occur, let's say, is 150 degrees Celsius. Okay, so this is a reactor. Then you have your raw material. Okay, let's say you have A and B. So your reaction is A plus B. Okay, let's say it's reversible. So you will get C plus D. Okay, So in order to get maximum C, because this is your product, the product you want, so the temperature, optimum temperature is 150 degrees Celsius. Okay, so this is what you want, right? So then you have A and B. So A is from tank, storage tank. B is also from storage tank. You use pump to pump your raw material from storage tank A and storage tank B to the reactor, right? But the temperature, you store A and B at room temperature, 25 or 30, let's say. Okay, 25 lah. Okay, so when you pump in, so if you don't heat it up before you pump it into the reactor, then the temperature difference is too high, right? The temperature difference is 125 degrees Celsius. Okay, so we don't want to affect the reaction in the reactor, right? Because if too much raw material pump in, then you affect the reaction, right? Because the temperature is at 25, your raw material. So what normally is practiced in the industry is before pumping in A and B to the reactor, then you need to preheat your A and B. Okay, so what they use for preheating, normally they use heat exchanger. Okay, so they install heat exchanger here and here. Okay, so to heat up your raw material, let's say from 25 to, let's say, 125. Okay, before the raw material is pumped into the reactor. This is where you need heat exchanger. Okay, let's say here in this, okay, this is your A or your B. Okay, your raw material here. Then here you have steam or hot water. Hot water cannot. In this case, it should be steam. Okay, steam. So steam go through the pipe here. Let's say the steam is at the temperature of 200 degrees Celsius. Okay, so steam pass by these tubes. Then your raw material A or B pass by your shell, because this is a shell and tube type heat exchanger. Okay, so this is where heat transfer happen. Okay, you heat up your raw material from 25 degrees Celsius. Okay, when it enters is 25. When it exits the heat exchanger, it becomes 125 degrees Celsius. You heat it up using steam at 200 degrees Celsius. Okay, so this is what will happen in heat exchanger, and this is what you are going to learn in the next topic. So that's why we expose you to heat exchanger first. Okay, banks of tubes. Okay, so when in your project, to complete your project in heat exchanger, one of the steps is to calculate this. Okay, there are many steps, okay, to do calculation, and you also need to do try and error many times. Okay, so you need to use Excel spreadsheet in order to complete that. Then you need to refer to a standard, international standard on the steps, how to do that one by one. Okay, that's the reason why in this topic of convection, we expose you to banks of tubes. Okay, because you need to apply this in heat exchanger, and this is the real process, right? In the industry, next time, let's say you work as design engineer, let's say, Okay, you work in a consultant firm. Okay, providing service to design heat exchanger to the industry, and then this is what you are required to do. Okay, so I want you to see. So banks of tubes. This is what you see, right? There are two types of arrangement: inline and staggered, right? When you do your project, right? Heat exchanger, when you refer to the standard, you will also see this inline or staggered. There is even another type of arrangement. Okay, so you see, this is the banks of tubes, right? So actually, the real situation is like this, right? This is the arrangement. So the fluid which you want to heat up or you want to cool down pass by here, then the cooling or heating fluid flow through the tube. Okay, then this is a shell. Okay, it's actually like this lah. It looks like this. This is how so-called a typical view of a heat exchanger. Okay, so that's the reason why we want you to learn about these banks of tubes. Okay, the other shape, for example, single sphere, not that common lah. Okay, not that common, or even a single cylinder. I think the most commonly used, right, which you will see in almost every chemical industry, is banks of tubes, because